sheet of paper. Yes, you are going to do corrections on them. I'm short on correction papers. If you feel like you're probably going to go ahead and start on corrections over the weekend, grab them. They won't be due till the very earliest. Okay. Yes, corrections on midterm will be on next quarter. Yes, that's fine. I just didn't pass them all out because I'm running short. I'll have them Tuesday. It's gonna be 20. But I mean, it will go in as 100 for your test grade until we have the Unit 3 test. So it's going. If you do all your corrections, it will look like you made 100 on a test for a while. So we have this test.
It's gonna be a 1 sheet or 2 sheet type of deal.
Maybe 2. I don't know. Maybe 1. We'll see. Could go either way. Not a lot of words to write, but there are several problems. Okay, so today we are going to look at using the chain rule to take derivatives. And it's going to allow us to take derivatives of some things that we have not been able to take derivatives of before. It's super fun. It has a cool name. I'm always wanting somebody to make a rap song about this one because I just feel like it. I feel like it just has like a rap, like that could be somebody's like rap name possibly. All right, maybe not right now. We don't need a freestyle chain and rap battle right now.
I'm gonna do that. I got you, Tommy.
Okay. All right, so chain rule is what we're going to use whenever we have a function inside of a function. Sometimes I use this analogy. I think my high school calculus teacher used to say this, like, if you ever have gotten a present before where like one of your aunts or uncles thinks they're funny and they like wrap like 4 boxes inside of each other, and you wrap, it's like a big box, and then like you unwrap it, and then there's a box wrapped in duct tape, and there's another one inside of that, and it's wrapped up in something else, and then you get like $5 in the middle of it or something. So if you haven't experienced this, then you're not in my family, because somebody in my family has done that several times. So like, we can think of chain rule a little bit like this situation. So whenever you have this present, you have to unwrap the outside box first. Then you get to the middle, and then you can even have more inside. Most of ours are just going to be, we got to unwrap like 2 boxes. Sometimes if I'm really feeling like we really need to do a difficult problem, there might be 3 times you have to use the chain rule. But the outside function is like your outside box, so that would be the F in this case. And then the inside function, what you have here, that's your inside box. In this case, it's your G. So you're going to unwrap the first one by taking the derivative of your F, but the stuff on the inside stays the same because that box on the inside is still there. It hasn't been unwrapped. Then you have to take this stuff that's on the inside, and you have to take the derivative of it, and you will multiply it by whatever you have here. So let's look at what this looks like in practice. So here's our first problem. We've got the square root of 2x minus 3. And so I've given you one of these before, but you've had your calculator to take the derivative. So we're going to learn now how to do this by hand, where some of those problems I've given you before could now become ones that would show up on the calculator inactive section. So the outside here is that square root. The inside is going to be this 2x minus 3. So your outside part is that square root. The inside part is the 2x minus 3. It will be a little bit easier, actually, for us here. If we write this, we've not taken the derivative, but we write it as 2x minus 3 to the 1/2. Correct. So, whenever we take the derivative of this outside part, the inside stuff stays the same. We treat it like it's just an x, like we're not doing anything to it. So, if I'm taking the derivative of that being to the 1/2 power, I'm going to multiply out front by 1/2. I leave the stuff on the inside exactly like it is. And then I subtract 1 from my exponent. I get negative 1/2. So that's taking the derivative of that outside function. Now I need to take the derivative of this inside piece, this 2x minus 3, which in this particular case is just 2. And so I multiply by that derivative. And then all you have left from here is really just simplifying to clean this up a little bit. This is the derivative. If it is free response, you could leave it like this if you didn't need to do anything else with it. Like, for example, on the midterm, on one of those problems that I asked you to take the derivative and it had like an e to the x in it, some of you did not simplify it at all. And then some of you simplified it way down. And some of you simplified it too far and messed up and lost half a point. But it didn't matter there. You could have left it like it was, or you could have simplified it. That one you did have to plug a number in later, so it might have made it a little easier if you simplified, but if you went too far, you might have made a mistake. So, same thing. Free response, you can stop here, but a lot of times these show up on multiple choice, so we want to know how to simplify them. Yes. Yeah, because that g of x is the 2x minus 3. So the derivative of 2x minus 3 is just 2. And so here, 1/2 and 2, 1/2 times, all this is multiplied, right? So 1/2 times 2 is 1. It's going to go away. And then I would probably move this back down to the denominator and put it in the root. Right, 1/2 and 2, we can multiply those together. Yeah. No x's. Because all of this stuff right here goes back down to the bottom and becomes a square root. That's it. You're done. This is your answer. We will have some like that. Probably not today. I don't think I have any like that today. We're also going to have some, just to let you know what kind of fun is coming down the road, where we might have to do chain rule, but within the chain rule, we might have to do the product rule or the quotient rule. So, what the hardest thing for most students with chain rule is recognizing that you have to use chain rule. Okay, so when you have sine of x here, this is sine of 8x. So it is not product rule because it's not sine times 8x. It is sine of 8x. Yeah, sine is like sine's like an operation that you're doing, not like there's no x in this part, right? Right. So the outside here. The outside is sine, and the inside here is 8x. So what is the derivative of sine? So we're going to have cosine of, don't change the stuff on the inside, cosine of 8x, And then we have to multiply by the derivative of the inside, which would be 8. Typically, this is going to be written this way, 8 cosine 8x. That's it. The problem is a lot of times students forget to multiply by that derivative that's on the inside. Okay. All right, questions?
No, we should have.
All right. Here's our next one. Okay, now, for example 3, is not product rule, but it could be quotient rule. You can use quotient rule for this. I don't like to. I don't like to use quotient rule for this because I like chain rule better. So the other way that you could write this is you could write it as x plus 1 to the negative 1. Now, you don't have to do it this way, so if you hate doing it this way, you can use quotient rule. Just be careful because the derivative of 1 is 0, and a lot of people still put it as 1, and then they mess it up. So, because this is on the bottom, it has a, yeah. So this is still f of x. I haven't taken the derivative. So this time, no. Get off that phone. I'm gonna let Rishi sit beside of you and tap you lightly on the shoulder every time the phone gets out. Okay. All right. So if we take the derivative here, we've got negative 1. Stuff on the inside stays the same to the negative 2 power times the derivative of the inside, which would be 1. Okay, you could leave it like this, probably on multiple choice or back of the book if you're checking your work. It's not going to be, they'll leave that negative 1 on top and they'll put the x plus 1 squared back down to the bottom. I will tell you that when I was in high school, once I learned this, I never did the quotient rule ever again. I technically don't have to teach you the quotient rule because you could now move every denominator to the numerator with the negative exponent and use, sometimes you might have to use product rule, sometimes you might have to. Then you would have to use product rule with a, but you could avoid quotient rule altogether if you wanted. And for some reason in high school, I don't know what aversion to the quotient rule I had, but I never used quotient rule. But there are lots of times I would prefer to use quotient rule now. But
I did quotient rule. It's gonna bother me.
yeah. So, and you can still use quotient rule. You'll get the same thing if you do it correctly. All right, let's look at this one. Now, this is a problem that you could have done before, but what would you have to do it before? You have to multiply that whole thing out. And you could use Pascal's triangle, but even with that, this one's still going to take a while to do that. So, chain rule makes this so much easier because we would have 5 2x minus 5 to the 4th power. We will multiply that by 2. you'll probably combine your 5 and 2. 10, 2x minus 5 to the 4th. Also, your answer choices a lot of times for a problem like this are going to look like this. So if you expanded it all the way out and took the derivative, then you'd have to factor it back to get it to match this, which would be nearly impossible to do. You'd have to use like P's and Q's and synthetic division, and it would be, that would be like that 1, 2, 3, 7, and then you had like this here, -1. There's like some, there are some rules you can use to like narrow down your guessing, but yes, it's guessing. It's still guessing, yeah. Yeah, so you could use this, but I used to give problems in calculus that had that in it, but I have not seen one on the AP exam in many years that actually had you do that, so I've quit doing it just because we got other things to focus our time on. Yeah. Okay. Noah, you're on the phone again.
He's on that joke every single day. That's like day 1. Yeah, get on. He's sick. Get on.
I've not. I mean, I know everybody's checking theirs occasionally, but I've not noticed quite the extent.
Yeah.
Noah, you're hurting my feelings. Okay. You know, I let you guys have your phones most of the time because in college they're probably not going to take up your phones. But you need to be policing yourselves on your phones because if you're checking them all the time, it is distracting even if you think you're, not. It's just not good for it's not good for all kinds of things for you to constantly be checking your phone. Okay. All right, so example 5. When we take this derivative, what do I do to take the derivative of 2x? It's just 2, right? So everything that's separated by plus or minus signs I'll just do separately. So I don't have to use a chain rule or anything right there.
Oh, that's just like it's like, yeah, because when it's separated by the plus or minus, it has to take it separately.
Yes. So over here, though, I have an x squared inside of a trig function, so I have to use a chain rule for this one. This 3 is just a coefficient, so I can just like leave it out front and think of this is my outside and this part is my inside, and hopefully you remember from yesterday what is the derivative of tangent? Secant squared of, we'll leave the x squared here, don't change that. So that's the derivative of tangent. Then I got to do the derivative of the inside piece, which is going to be 2x.
So we get 4x minus the 3.
You multiply by that derivative at the end. Yeah. All right, so now when you combine this, Thomas's 2x cannot go with the 2 because it is separated by that minus sign. And all of this stuff right here is multiplied. 3 times secant squared x times 2x. So you can put the 3 and the 2x together. So you'll have 2 minus 6x secant squared x squared.
And that's as far as you can go.
Yeah. Correct. Right. So if we just had tangent of x, it is the derivative is secant squared x, and then you would multiply by the derivative of the inside, but the derivative of x is 1. So whenever it's just an x, like you could apply the chain rule there, but it doesn't change anything. So, all right, we got a couple options on number 6. Okay, we could do a 3-box one. Or, if I have the cube root of x squared, how could I write that? X to the 2/3. That's going to make this easier to do. So before we take the square root, right there, let's write this is x squared minus 1 to the 2/3. So, Noah, tell me how to do this one. So our outside function is that to the 2/3 power. Our inside is the x squared minus 1. So we're not going to worry about the inside right now. Uh-huh. Right. Eventually we're going to be multiplying by 2x. What have we got to do to this x squared minus 1? It's just like the power rule. Like if we had x to the 2/3 power, we would multiply out front by our exponent. So I have 2/3, negative 1/3 right here. And then we'll simplify this. This 2x is like a 2x over 1. This is like it's over 1. So all this is multiplied together. So in the top, we would have 4x. That to the negative 1/3 would go to the bottom, so we'd get 3x squared minus 1 to the 1/3. You might see him change that back to a root. Like that.
No, it's not.
Jack and Thomas have differing opinions on the beauty of mathematics.
I mean, I understand it.
Okay. 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 So, example 7, we got a couple options here as well. We could use quotient rule. If you use quotient rule, you have to do a quotient rule with a chain rule involved. Because to take the derivative of this denominator, you would have to use the chain rule. However, because you just have a number in the top, what I would do is I would do negative 5, 3x minus 4 to the negative 2 power. All right, move that back up to the top. So when you do that, now you can just use the chain rule, which is going to be, in my opinion, technically anytime, yes, but if you have an x in the numerator anywhere, you're going to have to use product rule and chain rule, so it's not necessarily easier in those cases. But if you just have a coefficient up there, then it's definitely going to be easier to do this. You still sometimes have to use product rule. We're going to see that in number 8. But you could totally get around the quotient rule with chain rule if you wanted to. Yes. If you move it to the top, you'll have to do the product rule with the chain rule in there. Yes. Yes. Yeah, you do like 5x times, then you use chain rule to take the derivative of the second part. We'll do one like that here in a second, so we'll see it in a second. But for this one, it's just coefficient, so g prime of x. So let's see, our outside function here is that 5 times something to the negative 2. The inside is 3x minus 4. So Emerson, what are we going to do here? You can do it outside. We got to deal with that exponent. So what do we do with the exponent? Good. So we'll get 10 The stuff on the inside stays the same, 3x minus 4 right here. What do we do to our exponent here? Okay, so negative 3. So that takes care of the green box outside. Now we got to multiply by the derivative of the inside. What would that be? 3. Okay, and so they'll multiply 10 and 3 together and put 30 there, and then they'll move this back down to the bottom. Yes. 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 Ask me that again. No, just 1. Yeah. Kind of like if I ask you to multiply 2 times 3 times 4, you would do like 2 times 3 and then take that and multiply it 4. You would not do 2 times 3 and 2 times 4, right? So you would just multiply, just those coefficients multiply together once. You don't distribute to the other stuff. Okay, now, example 8 starts to get more interesting because I've got x squared times a square root. Unfortunately, it does not work like that, Thomas. If it was a square root squared, it would. So,
Would you do what? X squared times the chain rule of the second thing.
yeah, let's write this. I'm going to write it like this first. So 1 minus x squared. Let's see if Jack can do it before I teach it to him. See if you can do it, Jack. Yeah, see if you can multiply. So you got x squared. What would we multiply that by? Okay. I'm going to leave it like this, but you could do a square root. Yeah. Okay. So, you know the things that you need already for this. You're just having to put those together. So, let's look at what we did there. First of all, I rewrote this with a 1/2 just so it was a little easier to take the derivative of instead of the square root. So, this right here has to be my f of x. And this right here has to be my g of x. Because I've got two things that are multiplied together. Both of them have x's in them, so I have to use a product rule here.
Oh, so we just use the product.
Yep, so,
I didn't know that.
so this right here is f of x. This right here is the derivative. Oh, wait. I'll let you do it wrong. What did we do wrong here? Unless you said it and I didn't write it down, that's possible too. Times what? Not 2. What's the derivative of this inside? Negative 2x. This is g prime of x right here. So what we're doing is we're taking the derivative there. I'm going to do it over here to the side. The g prime of x. You're taking the derivative using the chain rule. So it's 1/2 times 1 minus x squared to the negative 1/2. Right. And then you got to multiply by the derivative of the inside, which would be negative 2x. There. So it is a product rule problem, but it's got a chain rule included in it. And then this piece right here is our g of x, and this piece right here is our f prime of x. Now, this gets a little extensive on the simplifying, right? So, and this is going to be stuff like free response. Technically, you can leave it here, but this is stuff that's going to show up on multiple choice part a lot. or that they need you to use this again, so it's going to be something you need to simplify. So for this stuff, everything right here is multiplied, the x squared, the 1/2, the negative 2x. So I would leave the 1 minus x squared to the, I'm going to actually leave it to the negative 1/2. There's a few ways you can simplify it, but I'm going to leave it like that. So the x squared, the 1/2, and the negative 2x can all be multiplied together. X squared is in the top, negative 2x is in the top, 2 is in the bottom here. So you got like negative 2x cubed over 2, which of course we can cancel those 2's and just get negative x cubed times 1 minus x squared to negative 1/2. For this part, we'd probably just write the 2x times 1 minus x squared to 1/2. Now, there's a couple ways that you can simplify this. I'm going to show you the way that I use most often. Notice that you got a 1 minus x squared here and a 1 minus x squared here. So, you could move this down to the bottom, get common denominators combined. This is the way that I typically do it instead, though. Because those two are exactly the same, we can factor it out and take the lowest amount of 1 minus x squareds that we have, which is going to be this negative 1/2. So I'm going to factor out 1 minus x squared to the negative 1/2. And when you do that, it's like you're dividing by 1 minus x squared to the negative 1/2 for both terms here. So if I divide this out, if I pull this out, it just cancels out and I have a negative x cubed right there. What's going to happen here, though, with the 1/2 and the negative 1/2? This is going to be 1. So let's think about that with like if I had a to the 1/2 over a to the negative 1/2, they're not going to cancel because one of them's positive, one of them's negative. But what it could do is it could send this up to the one top, right? So we'd have a to the 1/2 times a to the 1/2, and 1/2 plus 1/2 is 1. So it ends up being 2x to the 1 minus x squared. So if we took this and moved it up to the top,
Wait, why do you have
we're factoring that out. So when you factor something, like we don't usually write this, but like if we had 2x plus 4, right? If we pull the 2 out, what we're doing is we're dividing both of those numbers by 2, right? And so we get x plus 2 right here. So when we factor out negative or 1 minus x squared to the negative 1/2, we are dividing both terms. Right. They're exactly the same, so they cancel. Yeah, because the 1/2 minus that 1/2, or minus the negative 1/2 would just be 1 there.
Why is the x cubed up?
Yes, it was just negative from the beginning. Because we had this negative 2x right here on this derivative. Yes. Correct.
And the 2x doesn't change because it's part of the same line.
Right. It's like this negative x to the third that just stayed there here, right? It just stays there. It's this part's confusing. We're gonna do a few more. If we don't get to them today, we'll do them on Tuesday. But so we'll distribute here. Now this stuff now, I'm gonna send it back down to the denominator. So I'm gonna have negative x to the third plus 2x minus 2x to the third over 1 minus x squared to the 1/2, which is going to be negative 3x to the third plus 2x over 1 minus x squared to the 1/2. And this is typically the way they're going to leave it. They might change it back to a root in the bottom. Questions? Okay. We will. Let's see. Let me look at the. You're not going to have a lot that are that difficult. You're not going to have a lot that are that difficult on tonight's homework. We're going to do some more of the ones that are super difficult on Tuesday. You don't even have school on Monday. This is calculus. All right, so you can copy this down if you want, but these should be ones that you already know. We are primarily going to focus on natural log of x. There is a chance. I'm sorry. Never mind. I thought that was something different. Okay. So we already know natural log of x. Derivative is 1 over x. Hopefully. All right. So if we are going to take the natural log of u, let's say u could be anything here. U might just be x, but u could be x plus 2. It could be x squared. It could be 3x minus 4x squared plus 7. So if we take the derivative, so if we do this, we've got to use a chain rule here. Don't worry too much about this right here. Let's do a problem. Okay? So if we are taking the derivative of natural log of 3x plus 2, so this notation right here, d over dx, just means take the derivative of what's in these brackets. Whenever, like, if my function was given like this, y equals natural log of 3x plus 2, and I took the derivative, I'd write it like this, dy over dx equals, and then I take the derivative. If I see d over dx, it's not given in like an equation sort of form. It's just saying take the derivative of this stuff. So it's just a different way of asking the same thing. And we'll talk more about this dy dx stuff whenever we get to a different section we're going to talk about. But so right now it just means derivative of y with respect to x. But and this means take the derivative with respect to x. X is your variable. So far we've done nothing but take the derivative of x's. But we'll see in the next section that we can also take derivatives of y's. But we'll. Most people like that section. It's not that bad. All right, so this is just like showing you what the chain rule would look like. U could be any expression. Don't let it confuse you. So if you took the derivative, it'd be 1 over u, and then you'd multiply it. This is a way of saying the derivative of u, or you could use u prime, which is the derivative of u. But don't let that confuse you too much. Let's just do a problem. Maybe I should not even put it there.
Why isn't it just 1 over u?
Because if it's chain rule, you got to take the derivative. This means derivative of u. Yeah. Yeah. So when we take the derivative of this, natural log is our outside. 3x plus 2 is our inside. So the derivative of natural log is 1 over 3x plus 2. that u prime, this is just a different way of writing it. So du over dx means the derivative of the inside. U prime is a different way of writing that same thing. But what we know is we just need to take the derivative of the inside. What is the derivative of 3x plus 2? It is 3. Does that go in top or bottom? It is top. So we're going to get 3 over 3x plus 2. Now, derivative of 3x would just be 3. It's 1 over whatever's in the parentheses. No. I did not give. I occasionally will give them something, but they won't do it. So. Y'all are too advanced for things like that. Those test 2 grades would say otherwise. Midterm's looking much better though, so yes. Okay. It's an equal sign. You may go get some water if you need to try to recover. Somebody scare him. I think it's unlikely, though, hopefully. All right, so look at 10. This time, what is our outside? Fourth power. All right, so we're going to, and then the inside is our natural log of x. So this time, when we take our derivative, it's an equal sign. It's just, we'll have 4 ln of x to the third times the derivative of the inside, 1 over x. So this will probably be written like this. Okay. Questions? Yeah. Yeah. All right, here's our last thing that we're going to look at, I think. Isn't the last one? Yeah. All right, last one. All right, so our derivative of e to the x is just e to the x. But there were some problems like e to the 2x that I told you we could not take the derivative of yet. So that is when we have to use the train rule. So if we have e to anything besides an x, if it's a 2x, if it's an x minus 4, if it's x squared plus 7, then we have to use the chain rule here. So the derivative of e to the u is still e to the u, but you got to multiply by that derivative of whatever's in your exponent here, which is going to be pretty straightforward for these problems. Yeah, e to the u times u prime, which u prime is just the derivative of u. Yes.
So why is it d dx times?
This is just notation that means take the d over dx means take the notation of, so it's not actually being multiplied. It means take the derivative of this stuff. A u. Yeah. Or e to the u times u prime. Yeah. So On these problems, the outside is the e to the x, and then the inside is whatever is in your exponent. So when you take the derivative, it is itself, so it's e to the negative 3x. You don't change anything about that. But you must multiply it by the derivative of the inside box, which is your exponent, which is negative 3. Typically, that's going to be written this way, negative 3e to the negative 3x. And you may even see it look like this, negative 3 over e to the 3x, since you have that negative exponent. Okay. Questions? All right, so the assignment for, thank you so much. All right, so, thank you, Ethan. All right. Okay, so, all right, so homework is from page 168, 7 through 26. It's several problems, but there should only be a few that take you a little while, like that one hard problem. So, you've got 22 minutes that you could go ahead and get started on this. I would suggest that. It'll go on next quarter. It's good to know you value. Alright, test corrections, make sure I've got them. So if you hadn't given them to me yet.
Oh, yeah.